That haunting sound you just heard is often called the sound of Pluto. It's eerie, mysterious, and unlike anything we experience on Earth. It wasn't recorded with a microphone, though. During NASA's New Horizons flyby in 2015, instruments measured charged particles and plasma around Pluto, and scientists converted that data into sound frequencies humans can hear. As unsettling as it sounds, Pluto itself is even more extraordinary. Pluto is one of the coldest worlds ever explored. Surface temperatures can fall to nearly minus 230 degrees Celsius, cold enough for nitrogen, methane, and carbon monoxide, the same gases found in Earth's atmosphere, to freeze into solid ice. Sunlight reaching Pluto is almost 1,600 times weaker than the sunlight we receive on Earth, leaving the dwarf planet in a dim twilight that never resembles a bright day. For decades, astronomers believed this distant world was nothing more than a frozen, inactive ball of ice drifting through the outer solar system. But when NASA's New Horizons spacecraft finally flew past Pluto in 2015, it completely changed that perception. Instead of a lifeless landscape, New Horizons revealed a surprisingly dynamic world. Towering mountains rose several kilometers above the surface, enormous glaciers slowly flowed across vast plains, and a thin atmosphere surrounded the planet, stretching hundreds of kilometers into space. Some regions appeared so young that they contained almost no impact craters, suggesting that geological activity is still reshaping Pluto today. For a world nearly 6 billion kilometers from the Sun, these discoveries were completely unexpected. The most recognizable feature on Pluto is the giant heart-shaped region known as Sputnik Planitia. At first glance, it appears to be little more than a bright patch of ice, but it is actually one of the most fascinating landscapes ever discovered. This enormous basin spans roughly 1,000 kilometers across and is filled primarily with frozen nitrogen. Unlike ordinary rock, nitrogen ice behaves almost like a very thick liquid over millions of years. It slowly flows under its own weight, carrying fresh material across the surface and gradually erasing ancient impact craters. This constant movement explains why Sputnik Planitia looks remarkably young, despite Pluto being more than 4.5 billion years old. Surrounding the icy plain are mountain ranges that rise as high as 3 to 5 kilometers. These mountains are not made from granite or volcanic rock like those on Earth. At Pluto's extreme temperatures, ordinary water freezes into a material as hard as solid stone. The mountains are therefore built almost entirely from water ice, while the softer nitrogen and methane ices slowly move around them like glaciers flowing between rocky peaks on Earth. It is one of the strangest examples of geology anywhere in the solar system, where materials that are liquids or gases on Earth become the building blocks of entire mountain ranges. One of the biggest surprises came from Pluto's atmosphere. Before New Horizons arrived, scientists expected to find only a thin layer of gas barely clinging to the surface. Instead, the spacecraft photographed dozens of delicate haze layers stacked high above the horizon, extending more than 200 kilometers into the sky. These layers scatter sunlight in a way that gives Pluto a faint blue sky, an unexpected sight on a world so distant from the Sun. The blue color is created by tiny particles called tholins, complex organic molecules formed when ultraviolet sunlight breaks apart methane in Pluto's atmosphere. These particles slowly drift back to the surface, coating large areas with a reddish-brown color that gives Pluto much of its distinctive appearance. Although Pluto appears frozen and quiet, its atmosphere is constantly changing. As Pluto follows its highly elongated orbit around the Sun, temperatures rise and fall over decades. During the warmer part of its 248-year orbit, nitrogen ice on the surface slowly sublimates, changing directly from a solid into a gas. As Pluto moves farther away from the Sun, those gases freeze once again and settle back onto the surface as fresh frost. In effect, Pluto experiences seasons, but each season lasts for decades rather than months. Another remarkable feature of Pluto is its relationship with its largest moon, Charon. Measuring about half the diameter of Pluto itself, Charon is so large that the two objects do not behave like a typical planet and moon. Instead, they orbit a common center of gravity located outside Pluto's surface, making them more like a binary system than a traditional planet-moon pair. The same side of Pluto always faces Charon, and the same side of Charon always faces Pluto, locked together by gravity in a slow cosmic dance that has continued for billions of years. Pluto's orbit is just as unusual as the world itself. Rather than traveling in the nearly circular paths followed by most planets, Pluto moves along a highly elliptical orbit that is tilted about 17 degrees relative to the rest of the solar system. For part of its journey, Pluto actually comes closer to the Sun than Neptune. Despite this, the two worlds can never collide because they are locked in a stable 3-to-2 orbital resonance. Every time Neptune completes 3 orbits around the Sun, Pluto completes exactly 2, ensuring that the two bodies are never in the same place at the same time. Perhaps the most famous moment in Pluto's history came in 2006 when the International Astronomical Union introduced a new definition for the word planet. Under this definition, a planet must orbit the Sun, have enough gravity to become nearly spherical, and clear the neighborhood around its orbit. Pluto satisfies the first 2 conditions but not the third, because it shares its region of space with many other icy bodies in the Kuiper Belt. As a result, Pluto was reclassified as a dwarf planet, a decision that sparked debate among scientists and the public that continues today. While this official classification changed, Pluto itself remained exactly the same extraordinary world it had always been. More than 90 years after its discovery, Pluto continues to challenge our understanding of the outer solar system. It possesses flowing nitrogen glaciers, mountains built from frozen water, a changing atmosphere, mysterious organic compounds, and landscapes that appear far younger than scientists expected. Rather than marking the edge of exploration, Pluto has become a reminder that even the coldest and most distant worlds can remain active, evolving, and full of surprises. If you enjoyed exploring one of the most mysterious worlds at the edge of our solar system, don't forget to like this video, subscribe to the channel, and turn on notifications for more documentaries about the universe. And before you leave, there's another world you need to see. Neptune may look calm from a distance, but it hides the fastest winds in the entire solar system, storms larger than Earth, and weather so violent that even modern science is still trying to explain it. Click on the Neptune documentary on your screen now. You'll never look at the 8th planet the same way again.